Good.
So do you want to finish up this density and displacement, or do you have something new?
No, I have something new.
Okay, you want to send it to me?
Yeah.
Yeah, I had another student send me the back half of that displacement, and we went over those density questions earlier today.
I got those all right, though.
Okay, good. Yeah, those are pretty easy. Just weight is equal to volume times density. That's all you have to remember. There it is. My phone telling me that I have an email. Okay, so it looks like we're doing more surface areas and volumes. Good. This is really important stuff, actually. Whereas, I won't say that displacement and density wasn't important, but you're not likely to have it on the ACT test or any further math. So, in keeping with what we've been doing, let's write a general formula for volume for this object. What kind of object is that?
Like half of a cylinder.
Okay. So what's the formula for a cylinder?
Pi r squared times height.
And it's half, so I'm going to put the half right there in front. Okay, now fill in everything. What's R?
14.
What's H?
47.
Yeah. Now notice that H isn't always height. What H is actually is the thickness between the two bases. In this case, it is 47, but this thing is laying flat. So it'd be hard-pressed to call that a height. I prefer almost to call that a thickness. Okay. Now, surface area. Do we need to go through this, or are you good to go once we get it to this point?
Oh, yeah, that's fine.
Okay. So, surface area. For a whole cylinder, this is going to be a little bit different. In other words, we can't take the surface area of a whole cylinder and cut it in half, because this actually, the flat base that it's on, we're going to have to count that. Whereas if we had an entire cylinder, there wouldn't be any bottom portion to it. So we're going to have to break this up into pieces. So what is the area of this bottom base that it's sitting on?
47 times 28.
Okay, we're going to add to that the combined bases. Well, 2 half circles make a full circle. So what is the area of both of these bases?
196 pi.
Okay. And finally, the toughest part is the curved part, the lateral area. Remember how we did it for a full cylinder?
The circumference times the height.
Good. In other words, think of it as a soup can with a label on it. If you peel the label off and stretch it out, you're looking at a rectangle. And that rectangle is going to have, that's going to be half the circumference. So it's not the full circumference, it's half the circumference times its height, right?
Okay.
In other words, if we take this curved area here and flattened it out, it would be 47, would be one dimension. This would be 47. But the top dimension would be half of a circumference, correct?
So it should be pi. Wait.
What's the circumference?
If this be one of them, then it should be pi 14.
Yes. In other words, instead of 2 pi r, well, let's write it as 2 pi r. That's the circumference. But we're only dealing with half of it. Not because it's a half of a cylinder, but because it's half of a circumference. In other words, my general would have been 1/2 of 2 pi r. Well, conveniently, those cancel. So what's our answer for surface area? What are the instructions on this? Are they to leave everything in pi, or are they to turn it?
Yeah.
Okay.
We should just leave it in pi.
Good. Then let's follow through and make sure you know this. What's 47 times 28?
1,316
What's the rest of the answer?
plus 210 pi.
Correct. And that is the proper way to give the answer, as two separate entities, because pi is involved. The other way is we could convert it to 3.14, and then we could add those two numbers together. But if you're going to leave your answer in terms of pi, you have to leave it as two separate numbers. For 16, what's the first thing I should write?
Base times height.
The general formula. I'd like to see you begin every single problem with the general formula. Because once you write the general formula, you really can't go wrong after that. The difficulty is most people don't start their problems with the general formula. We're talking volume here. So what's the volume? Of a rectangular solid. I'm a little nervous with you using the term base. I'd rather use three linear terms. In other words, width times length times either height or depth. Those are the three dimensions. That's the general formula. Now, specifically for this box, what is it? And it doesn't really matter which one you call width, length, or height. What's important is that you recognize that it's the three dimensions multiplied together. So what is it?
17 times 8 times x.
And in this case, they're giving us the volume. So we're going to fill volume in for there. And that's equal to 17 times 8 times x. Which means x is equal to that whole thing divided by 17 times 8. You notice that once you start with the general formula and start plugging in what they give you, you're always left with just one variable. One variable you can solve, always with one equation. Still volume. No surface area question here. General formula for volume of a trapezoidal prism. Now it might be correct to say base times thickness or height, as long as you're very much aware that it's capital B times height. And now let's get more specific with our general formula. And I don't mean plugging in numbers, I mean, what is that?
Base 1 plus base 2 divided by 2 times h1 times h2.
Times that. In other words, the base is that. Oh, excuse me. Yes, times h1, that's the base. That's the formula for capital base. That's the area of that prism. And we're going to multiply it by a different h. Because this h here is that h right there. The second h, h2, is this distance between the two trapezoids, which is 42. So now plug in everything we know.
12,558 equals 17 plus 29 divided by 2 times h times 42.
Again, only one variable, the first h. If you have any questions at all about how to solve these equations, make sure you say something. Because I'm going to assume that when I get to this point, we're done. In other words, I assume,
can I divide?
Sorry, what?
Can I like divide 42 by 2 and then divide by that by 29?
Yeah, for sure. Always simplify first. Now, that means I got to put parentheses around that, which I probably should have done in the first place just for clarification. It would be a mistake to do that, to cancel out the 2 and the 42 without parentheses, because now you're going to go 17 plus 29h, which isn't correct. It's 46h times 21. So the parentheses are important there. Anytime you see an expression like that and you're going to get rid of the 2, well, this whole capital B or B1 plus B2 over 2 is being multiplied by h, all of it. General formula for 18. What's the formula for the volume of a hemisphere?
2/3 pi r cubed.
Good. In other words, we started out, the volume of a sphere is that. Well, a hemisphere is half of that, so it becomes 2/3 instead of 4/3. So that's the volume of a hemisphere. But this isn't quite a full hemisphere. What part of a hemisphere is this?
It's a sector.
What percentage of the hemisphere are we looking at? What percentage is cut away?
60, so we're looking at 300.
So what percentage is still there?
300.
300 divided by 360. That piece of the hemisphere is the piece we have. In other words, this whole outside is this percentage of the full hemisphere. Now let's plug in everything we know. I simplify that a little bit, but I don't take the trouble to simplify it completely just because it's not really necessary. In other words, I still can do a lot more simplification, right? In other words, I can cross out that 3, make that a 10. I can cross out that 2, make that an 18. Now what do I have? 7680 pi equals pi r cubed divided or times 10 over 18. Now I can cross out the pi's. So now r cubed is equal to 18 over 10, the reciprocal, times 7680, no pi. Now I can cross off that 10 with that 0. And now r is the cube root of that product. You know how to find cube roots on your calculator?
Yeah.
Okay. General formula. And it's the general formula for volume. Notice that they're not talking surface area. If they were talking surface area, then we'd need the surface area general formula. But the general formula for the volume of a cone is what?
Base times height divided by 3.
Okay.
So pi squared divided by, or times.
Make a comment and you can do with it what you want. I always remember this as 1/3 is the first thing I say. When I have an object that goes to a point, whether it's a cone or a triangular prism, or not a prism, a triangular pyramid or a square pyramid, they all go to points. They all are 1/3 of the volume that it would have been if it was a prism. In other words, if this thing was a prism, it would be a right cylinder. Okay? So it's 1/3 of the base, which is pi r squared, times the vertical height. The only objection I have to the way you gave it to me was a lot of students will forget to divide by 3 as the final step. In other words, they'll remember that, but they don't remember that it's divided by 3 or by 2. In the case of that trapezoid, I would have told you it's 1/2 of B1 plus B2, as opposed to B1 plus B2 divided by 2. When you put the denominator last, it's easier to forget. Whereas if I'm always remembering, the moment I see that point, I'm putting 1/3 down. The moment I see that we're looking at a cone. Okay, fill in everything we know. What's the next line?
2,420 pi equals pi r squared times 60 divided by 3.
But notice that we're solving for r, right? And r is the distance from there straight across to there. That's okay. Once we solve for r, we're going to be able to figure out x, right?
Yeah.
We're going to have a right triangle. If you view it from the side, you're going to be looking at the right triangle. So it's okay to solve for r. In this case, let's go ahead and do it. Let's first of all do that. And cross out the pi's. So what do we have? R squared equals 24/2 divided by 2. Cross out the zeros. So r squared equals 121. What's r equal? Square root of 121?
11.
So now we're looking at a triangle from the side view, where this is 60, this is 11 that we just solved for. What's x equal to? Solving right triangles is one of the most common things you're going to do in geometry. You really want to get good at knowing how to solve for the hypotenuse or how to solve for one of the short sides. In either case, the answer always begins square root of. So let's write that. And people, that's what they leave out, is the square root whenever they make a mistake on solving right triangles. It's almost always because they leave out the square root sign. So what is it the square root of?
11 squared, 11 squared plus 60 squared equals c squared.
Well, that's the Pythagorean theorem. But if you have to go back to that as your starting point, every time you solve a right triangle, you're going to be doing a lot of steps in math that you don't need to be doing. In other words, if you remember that directly, instead of having to solve for c, obviously if I solve for c up here, I take the square root of both sides, you still get that, right? So this is what I want you to memorize. Now, you can come up with a number for that. I'm not concerned about that, and that's going to be your answer. But let's say you were solving for one of the short sides. And let's just make that side be 100. Now what is x equal to? Directly.
A 3, 4, 5 primitive.
Make that 110. I didn't want to give you a 3, 4, 5 triangle. I want you to memorize the Pythagorean theorem for solving for a short side of a right triangle.
Oh, it's 60 squared plus b squared equals 110 squared. Or 6 and 11.
That's the Pythagorean theorem. That causes, if you go back to that step, you have to do an extra step every time you solve a right triangle. So if you can memorize the direct answer, what is it? It's square root of what?
It's the square root of 6 and 11.
No, it's the hypotenuse squared minus the square of the other side. Now, notice what these two equations are. If you're solving for the hypotenuse, it's always addition taking place under the radical sign. If you're solving for a short side, regardless of which short side it is, it's always the square root of the hypotenuse squared minus the other short side squared. So if you can memorize those two equations, now obviously the x is not the same here. I should call that the hypotenuse is equal to that, and the short side is equal to that. But if you can memorize these two, you can always go directly to these, and you don't have to start at the beginning. And that's pretty valuable because you're going to be doing it about 500 times over the next 3 years. I'm not exaggerating either. You're going to be solving right triangles at least 500 times. By the time you take your ACT test and your SAT test and any higher math that you take, tons and tons of solving right triangles. So if you can go directly to these formulas, you get them a lot quicker. Because you basically save a step. I mean, I'm a big proponent of memorizing the original formula and then doing everything from that, except in this case. This is one of the few cases where I don't like that technique because you have to do it so often. Only because you have to do it so often. Notice that if I'm solving for one of the short sides here, I get a squared equals c squared minus b squared, which means a is equal to the square root of c squared minus b squared. So I can always figure it out from the Pythagorean theorem, but it takes a couple of extra steps to get to the meat. You okay with doing these kind of problems the way we did that first one?
Yeah.
There was some question last time we worked together. You said your teacher gave you a special technique for figuring these out, and it may end up being the same thing. I don't know. I wasn't familiar with it. But the way I know how to do problems like this is to figure out what percentage of a right cylinder that you have. Okay, it's the general formula.
For 21.
20.
20. Okay. 360 or x over 360 times
Hold on. Let's take the general formula of a right cylinder. Let's start there.
Pi r squared times height.
Now let's multiply that by the percentage of the right cylinder that we have. It's not x over 360. That's going to give us the area of this, or the volume of this missing piece. So what's the entire piece?
360 minus x.
Yeah, it's 360 minus x divided by 360. That is the percentage of the cylinder that we have. Let's say x was 30 degrees. Well, we would have 330 divided by 360. That makes sense. Okay? Always make sure that things make sense. In other words, if I do that, notice that if x were 30, I'd be getting the volume of this tiny little missing piece here. I wouldn't be getting the volume of the rest of the solid. So it's very important that you use 360 minus x, not x. Okay, fill in everything. What's the next line?
5,075 equals 2.
Don't forget the pi. That pi is awful easy to overlook. Why? Because it looks a lot like that m. And in fact, if this were millimeters cubed, we'd have pi mm, and you'd have to look really close to see the pi. But know that when you're dealing with circular objects, pi is going to be in the volume every time. Whether it's a right cylinder or a cone or a part of a right cylinder, the volume's always going to have pi in it. So that's the volume equals pi times, what's r? 15?
15 squared times 28 times 360 minus y over 360.
Minus x. Okay, notice that again we have an equation with only one variable right there. So this becomes not tricky algebra. Everything's being multiplied, so the very first thing I can do is cancel those two. Do you have any questions about how to solve that rest of that?
Nope.
Okay. It's 8 o'clock. It looks like we got one more unsolved problem. Let's just talk about it quickly. What's the general formula?
Base times height.
No, remember it goes to a point. So start off with 1/3. And when you say base times height, from now on, I'd like you to say capital base, capital B. Because it's a lot different than little b. Capital B is an area. Little b is a linear measurement. So it's capital B times height. What's capital B equal to?
ASN divided by 2.
What's the other formula for it?
One-half.
There's two of them. That's one. There's another one that actually we need for this problem. What is the capital B in terms of perimeter? S is side length, N is number of sides. So what's the perimeter?
The perimeter is S
Times?
side length N.
Okay, so I can rewrite this thing that way. And that's particularly valuable here, because we don't know how many sides there are, and we don't know the length of each side. They don't give us any of that information. It's hard to even figure out how many sides there are to that base because of the way they've drawn it. I can't tell if it's 6 or 7, but it doesn't matter. As long as we use that formula, the bottom one, well, if we're going to use the bottom formula, volume equals 1/3 of 1/2 apothem times perimeter times height. Volume is 5684. Notice no pi because there's no circular objects here. You don't end up with pi in your answer if you don't have circular stuff. 1/2 times 1/3 is 1/6. The apothem they give us, 14.5. Perimeter is what they're asking for, and the height they give us, 24. Only one variable, the perimeter. Notice that if we'd used the other equation, we'd have had two variables. We'd have had S times N, and we don't know either one of those. We don't need to know either one of them, because all we need is the perimeter. That's all they're asking about, the perimeter of the base. I can figure it out once I get to that point. So I guess the moral of the story is that when they give you two formulas for the area of a regular polygon, memorize both of them. Because if you only memorize ASN divided by 2, you can't solve this problem. I mean, you could assume there are 7 sides, but that's quite an assumption. And then we'd solve for the length of each side. We'd solve for S, and then we'd multiply S times 7 to come up with the perimeter. But it's much easier if you just use the perimeter formula. Then you don't have to worry about what S is or what N is. Quade, you good to go?
Yep.
All righty. Talk to you next time.
Alright, thank you. Bye.
Have a good weekend.